right, peeps, in this video, we're gonna learn how to do something called complete the square. I'm gonna go over how to do it and also why it works. And then in a later video, we'll have some more practice of completing the square problems. Let's dive right into it. So what does it mean to complete the square? Well, you're given something that is typically going to be a trinomial, right? So it's almost always actually going to be a trinomial, if not always. So you're given x squared minus 6x plus 3. So something in the form ax squared plus bx plus c. Completing the square, what that means is our end goal is that we want something that looks like this. So x, and then you're going to have either plus a number or minus some number there. So it could be plus a, it could be x minus a, something like that. So you want this to be a part of your answer. That completes a square. Now here's the thing, this doesn't even factor as it is. So how do we get this to look like that? Well, it's very cool actually. What we do is you focus in on the first two terms right here. And a lot of people will learn this with a formula. I'm not going to teach it that way. I'm going to teach it the way that I know best, which is to teach it so that you understand why. And then the formula might make sense to you later, or you could just do it this way and you'll be good for the rest of your math lives. So what I do is I look at the first term, the x squared term, and the linear term, the x term. You always divide this term by 2. And you might be like, well, why? Well, what we're doing here is we're looking to get something squared. So I know that I have to put an x here because when I square this out, I need x squared. I'm going to divide negative 6 by 2. And what is that b term divided by 2? It's negative 3. So this is going to be minus 3. And you might be like, well, hold on a second. Why did you do that? Let me show you. Off to the side here, if we have x minus 3 squared, that's x minus 3 times x minus 3, which ends up, when you FOIL it out, being x squared minus 3x, then the inner is also minus 3x, and the outer is minus 3 times minus 3 is 9. So we get x squared minus 6 plus 9. Now you might be looking at that being like, yeah, but Mr. Grodin, this is not equal to that. No doubt. But this is equal to that. Right? So we're in good shape right here. Why did we divide by 2? Because when you square something out as a binomial, you end up with 2 of that same factor right there. So we're wanting to get to 6x, and we know that we're going to double whatever number goes here to get to that 6x when we complete the square, because you're going to get 2 of the same number. So how do we undo doubling to get there? We divide by 2. Awesome. All right, so now that we have this, now we do a little bit of extra work. We look at that and we say, I just added 9 to this problem. You might be like, what do you mean? Remember this? We just added 9 to the problem. When you square out that negative 3, it's 9. Now we had the 3 from the original problem. You added 9 to the problem. You can't just add 9 to something and expect it to be equal to what it was. So if we're going to add 9, we also then need to subtract what we added. Subtract 9. Nice. And now we simplify. So you get x minus 3 squared. There's the completed square, 3 minus 9 minus 6. This is equivalent to that. Again, the key steps are divide the b term by 2. We saw why that is. And that's going to give you your completed square in here. Then take a look at what c value you would get out if you square this. We ended up looking at that and saying, well, I added 9. Subtract out that very same value to balance it out. You can't add a number to an original expression and expect it to be the same unless it's 0. So by adding 9 and then at the same time subtracting it, we're adding 0, which that we can do. And to check your work, all you have to do is multiply this out and subtract the 6, and hopefully we end up back here. So let's check it. X minus 3 squared, we already did all that work out. It's x squared minus 6x plus 9. We did that out earlier in the video, minus 6. 9 minus 6 is 3, and look where we end up, peeps. Right back where we started. So we're not solving for something, we're really just manipulating this. And you might be like, why do we have to get something in this form? For now, it's just a tool. I'm teaching you how to use that tool, that technique. We'll use that technique to solve equations in a little bit, and then for something really wicked cool and a little farther down the road. All right, I'll see you in the next video where we'll practice this. Watch this video again if you need to see to divide this number by 2 and then subtract out what you added into the problem. It's a ripping good time. I loved it. See you soon.